Okay, so I really like the Number File YouTube channel. If you guys get a chance to get out there and take a look at it, please do. So they're talking about how in the Great London Fire of 1666, they had to rebuild St. Paul's Cathedral and they decided to use a dome. And apparently, I forget the architect's name, but I am familiar with Dr. Hooke's law and other physics related things. And essentially, he takes a piece of string, hangs it, and says, "Hey, let's draw this, flip it upside down, and from there we'll have a really, really good foundation for a dome." And the formula is a function of x. As you see here, it says, how do I get from here? Y equals e to the x plus e to the negative x over 2. And that's great, but what if you're given a y value and you need the x? Well, then we get into something called inverse functions. So essentially you turn the f of x into a y, which I've already done, and then the rest of it's, of course, to there. So what you do is you literally solve for x. And logarithms are tricky for some folks. Logs essentially allow you, they're numbers themselves, and they represent exponents. This is not a technical thing. I'm just making it real lay termy, okay? They're numbers that when you add them will give you back factors. So long story short, a guy named Napier invents them. And Vernier, he invents a vernier, something like that, as a vernier. And what happens is you can take two rulers. If you get two 12-inch rulers and you put them next to each other and you line up the numbers and you move the edge of one ruler, say the index, say to the upper ruler number 2, and you count over the number 6, the number immediately above that is an 8. So you take two linear scales and you can add numbers. Well, what he did is he took a logarithm, two logarithmic scales, and you can do the same thing. Now, once you add logarithms, you can get roots, square roots, cubes, cube roots, all right? And so what this does is this essentially turns the exponent into a regular number that we can use. So what we want to do is we'll write everything in terms of y, and there you have it. Again, e to the x plus e to the negative x over 2. And we'll divide both sides by 2, multiply both sides by 2 to clear the denominator, all right? And after that, I don't like using like 2y. That's kind of a pain. So I go ahead and turn that into u, right? Later, I'm going to turn that back into 2y. But for right now, let's just use a variable u, and it makes everything short and sweet. Now, the thing is, I have that negative exponent, which what that means, guys, is literally 1 over e to the x, okay? So what can we do to do that? Well, we can multiply everything by e to the x. And that will clear that negative exponent, which literally clears the denominator, okay? So I have u times e to the x squared equals e to the, u to e to the x, u times e to the x, see, this is even confusing for people who know how to do this, equals e to the x times the sum of e to the x plus e to the negative x, all right? And what that does is give us e to the x squared plus 1. Because any number over itself is equal to 1. Ooh, but look at this. I have a coefficient in front of that e to the x of 1, and I have a coefficient in front of, e to the x squared of 1. E to the x has the u, and I have a plus 1. You know what we can do? We can rearrange the whole thing into a quadratic. Now I have a quantity squared minus a quantity plus 1 equals 0. All right. I have another video out there. You might want to look this up and how I did what I'm about to show you. It's a simplified version of a doctor's simplified finding the x's via the coefficients. I know you guys are familiar with x is equal to negative e plus or minus square root of b squared minus 4ac all over 2a, all right? That whole thing, and his name is escaping me, though I can see his face. He has a 40-minute video out there. Even another aficionado that I follow, Presh Talwalker, again, go out to his channel, Mind Your Decisions. I'm Presh Talwalker. Love that channel as well. And he kind of explains how this doctor figured out the short version. Apparently it was discovered some 2,000 whatever years ago, but hey, he rediscovers it, puts his name on it, woohoo. What I did is take that and simplify it even further. So if you're not familiar with what I'm about to do, go ahead and look at that video. If I know how to do this, I'm not super savvy on YouTube, but I will try. Well, I'll put the link down in the description for you, all right? So here's the deal. We're going to go ahead and find the numbers of what e to the x equals, okay? So what I've done here is I've gone ahead and took the opposite of u divided by 2, and then plus or minus the root of, I simply square u over 2, and then I take the opposite of the c, which is 1 at this point, okay? And all that means now I'm just going to simplify. The 1 turns into 4 over 4. I have a common denominator. I now have u squared divided by 4 over 4. And I'm going to turn u back into 2y at this point. When I do that, the 2y, of course, u squared becomes 4y squared, all right? And now I'm just going to go ahead and clear those. I'm going to clear that denominator in my radical and clear the denominator under the 2y. So the 2's are going to cancel, the 4's are going to cancel, and I'm left with e to the x equals y plus or minus square root y squared minus 1. Now here's the fun part. What I do to get x is I multiply e by the natural logarithm. What that does is cancel the e out, okay? Essentially, it takes the x, throws it in front of the ln, and the ln and the e actually cancel itself out, but leaves the natural logarithm times that whole spiel on the right side of the equation. So let's do that. We'll multiply both sides by the natural logarithm, and then we're going to just, the ln and e on the left side is going to evaporate and leave us with x, and it's going to leave us with the natural logarithm of y plus or minus the square root of y squared minus 1. So all you have to do is plug in numbers. For example, this particular function loves the intersection of y equals 10 and x equals 3. So if I'm and the coordinate then is 310. It's really, really close. It's within a hundredth. So if I drop, if I go ahead and drop in 3 where it's at x, all right, it'll also give me 10 where it says y. So what I did is I just plugged in the 3 everywhere there was an x, and I plugged in a 10 everywhere there was a y. And if you run that through your calculator, you're going to find out that those equations are perfect. All right. So if I'm given y equals 10, it will return 3 as a value of x. That's the top equation. And if I'm given x equals 3 in the bottom equation, it will return a 10 for y. So what I've done is I've taken the how do you get from here, function of x equals e to the x plus e to the negative x over 2, and I've arrived at its inverse function, f of x with that little minus 1, okay, or just call it x, equals the natural logarithm of y plus or minus square root of y squared minus 1. And quod erat demonstrandum, that which was proved. We're done with this particular video. Hope you enjoyed it. If you did, like, subscribe, and share, and we'll see you guys on the next one. Thank you for watching. Have a great one. Bye.